Ever wondered how microphones work? Why not build one and see how it works at the most rudimentary level? In our transduction video, we showed you how simple a mic was by showing one we built from scratch. Now, we're going to take you through exactly how to build a mic just like ours that you'll be able to connect to any powered speaker, preamp, or interface to use. Here we have all the materials you'll need to build your microphone laid out. You'll need 2 ceramic ring 1/2-inch thick magnets. In our photo, these are already taped together with electrical tape, something you'll need to do. In addition, you'll need 1 1/4-inch by 2-inch zinc fender washer, 1 1/2-inch by 2.5-inch zinc fender washer, 1 1032 metal washer, 1 1032 hex nut, 1 1032 by 1 socket head cap screw, 30 feet of 32 gauge magnet wire wrapped around something tubular. We used a tube of chapstick, a plastic straw, and a 20-ounce plastic cup with a lid. You may also want to have a screwdriver and some kind of vice grip handy to help with the magnet assembly. In addition to building your microphone, you'll also want to test it. For this, you'll need a standard XLR cable, wire cutters, 2 pairs of alligator clips, and some kind of powered speaker, preamplifier, or audio interface to connect the mic to. So now that we have all our materials, let's start building the mic. The first thing we want to do is put our magnet together. Here you can see the 2 ceramic ring magnets taped together with electrical tape. Take the 1032 washer and place it onto the screw. Then, take the 1/4-inch by 2-inch washer and the 1/2-inch by 2.5-inch washer and place them on either side of the magnet, making sure that each covers a respective ring. Once that's done, take the screw and insert it through the hole of the 1/4-inch by 2-inch washer from the outside. This can be a little bit tricky since these magnets are powerful and your screw is metal, so it'll tend to stick to the side of the magnet. Once you've gotten the screw all the way through the magnet, screw the nut on from the opposite side you placed your screw through to lock it in. This is where you may want to use a screwdriver and a vice grip to help you. You may also wind up taking off the 1/2-inch by 2.5-inch washer, which is perfectly fine. Just remember to place it back on when you're finished. Again, take extra care to make sure your nut is locked on tightly so that the main part of your mic is as sturdy as possible. This magnet is our transducer for the microphone. Place it inside the plastic cup as shown here. This cup acts as the body of the mic, housing the magnet. Now that your magnet is done, let's make the mic's coil. Unroll a bit of the magnet wire before wrapping to act as one of the leads. Then, begin to wrap your coil around the straw. If you're using a straw with a bend in it, make sure that you're wrapping on the side of the straw without that bend. Take care in making sure your wire is wrapped snugly around the straw and that you leave enough room at the end for a second lead, about 6 inches to a foot. These leads will stick out of your cup. When you have enough wire wrapped around the straw, use electrical tape to tape part of the leads down, which will help prevent them from moving all over the place. Use a key to scrape enamel off both leads, about 2 to 4 inches worth. If you have it, sandpaper also works really well for this. Make sure you're scraping gently and rotating the wire as you go to make sure you get all sides. Furthermore, we put a piece of white paper down to make sure that we didn't scratch the table we were working on. Stripping the enamel off this wire will allow us to connect directly to the conductive copper, which we need in order to transmit an electrical signal from our mic to a receiving device. Now that our leads have been stripped and our transducer and coil are ready to go, let's put all our materials together. Take the straw and place the side opposite the leads through the plastic lid. If there's a bend in the straw, make sure you place the lid past that. Then, place the straw down so that the screw goes through the opening, as shown here. Pull the leads out of the side of the cup and snap on the lid. Congrats, you have now built a fully functional moving coil microphone. Now that our microphone is built, let's test it out. In order to connect your mic to an XLR input, the standard connector for a microphone, you need to make a cable with an XLR male plug at one end and a bare wire with alligator clips attached on the other end to connect to the leads from your cup. Using wire cutters, first cut off the female connector of an XLR cable. Then, strip the outer part of the cable off to reveal 3 different leads. 2 are coated wires, and the last one is braided around those 2. On some cables, there may also be some extra material to reinforce those wires. Cut off that material and ignore one of the coated wires. We don't need it for this. Finally, strip the colored lead and attach one alligator clip to the braided wire and another to a bare wire lead. Your cable should look like this. Time to fire up the mic. Take your modified cable and insert the male XLR plug into the input of whatever device you're using, in our case, a powered speaker. Then, as we mentioned before, connect the other end of your cable to your mic leads via alligator clips. Once that's done, turn up the volume on your device and you're ready to go. So as you can see, with just a few simple materials, you can build your own microphone, which you can use for special effects or just to impress your friends.